Hey everybody, so pleased to have for our next session the management team from Archer, Adam Goldstein, co-founder and CEO, joined by Brett Adcock, co-founder and co-CEO. That is Adam Goldstein on the right, Brett on the left, and unless we're inverted, but I think we're good. Thank you very much for joining us. Just to get this out of the way on the top, this webcast is for Morgan Stanley clients and approved observers only, not for members of the press. For important disclosures, I will refer you to www.morganstanley.com/research disclosures, and Q&A will be conducted electronically. I see well over a couple hundred on the webcast right now, so this is clearly the most popular of the sessions of the day. And I do want to thank the Archer team, Adam and Brett, for being an early, I'd say, an anchor sponsor of this inaugural summit, and a really important strategic partner as well. They helped us give a lot of input and connection to bring in some of these other non-corporate kind of industry level experts as well. And so I want to thank you both for that, for being an important part of the event. I'm joined by Christine Lewag from our aerospace and defense team as well for the fireside discussion, and I'm sure we're going to see questions coming in. So with that, Adam and Brett, just wanted to kind of give you a chance off the top, couple minutes to emphasize the Archer mission. The points that you wanted to get across to this investment audience that might be most differentiated, and where your value proposition is, and we'll go from there. Thanks again.
Yeah, thanks, Adam. Thanks for having us. We appreciate it. Maybe hitting it from the top, Archer is designing, manufacturing, operating electric vertical takeoff and landing aircraft used for urban air mobility. As you probably believe, we think it's going to be a very large market over the next couple of decades, and we're really excited about helping move people kind of off the ground in a lot of routes that take too long, and moving them into the air in a far more efficient and hopefully very affordable means of transportation for the masses. We have here at Archer and a really incredible team we put together across commercial aviation and other various parties that are helping to kind of commercialize this technology, certify it, manufacture it, and bring it to market. And we have two really unique partners here with us today along that journey. The first is Stellantis, which is the formation of Fiat, Chrysler, and Peugeot. We announced earlier this year we would be working with them on high volume composite manufacturing and other various design initiatives. And the second is United Airlines, which bought $1 billion pre-order of Archer aircraft, with an additional $500 million option. They're an investor in the business and also a strategic partner on helping accelerate our time to market.
Oh, great. So, we had talked earlier, we were, maybe we'll do it another time, this idea that you could give a virtual tour of the aircraft. Well, definitely look forward to doing that another time. But if you were there with a handheld or a selfie stick or something, what would be some of the attributes of your aircraft design that you'd want to highlight for this investment audience?
Yeah, well, maybe I'll give a quick plug too. We are going to be doing a vehicle unveiling where we would invite Morgan Stanley and your clients and the general public to come see that. So that'll be here in the very near term. So we will do kind of that full walkthrough. We didn't want to get too far ahead of it, but I think what you'd see is a vehicle that's been fully built and will be one of the future products of helping move people around. And so the vehicle really was designed in a way to get to market very quickly and be able to move people around in a very efficient manner. So the vehicle has 12 motors and rotors and is designed to take off and land vertically and fly forward on a fixed wing. It's the vehicle that you'll see on our website, the Maker aircraft. The vehicle has, I think, a really sporty look, a really sporty interior. We're excited to show it off to everybody. And I think, some of the things that are really important about it is, we've designed the vehicle to go 60 miles at the end of its battery life and including reserves. The vehicle will fly 150 miles per hour. And it's important because we'll operate in and around urban environments with our value proposition being saving people time. And so if we look at all these different routes where people are generally driving 60, 90, 120 minutes, where we think we can replace those routes with this type of solution and save people a lot of time and really kind of expand even some of the typical choices they would make and where they're going to travel. So you can look at a typical case study like Manhattan to JFK, but you can also look at, some really exciting things to help you go out and explore the world in a way that you might not have because it was less convenient. So for example, we're in Palo Alto right now in our headquarters. If we wanted to go up to Napa on a Wednesday or Thursday, you really wouldn't do that during the week. That'd be kind of a pretty, it would just take too long. And so with a vehicle solution like Archer, you could do that. And so it really tries to open up, the possibilities here, which we think will make the world just an exciting place.
So Adam, you mentioned a number that just brought ahead a technical question I was going to get into later, the 60 miles range at 150 miles an hour. You said that includes the reserve, meaning that just so I'm clear of including, meaning that the reserves are on top of that.
Yeah. So I think everybody in the industry quotes kind of range a little bit differently, but we try to quote it from the most conservative perspective. So, we're doing VTOL takeoff and landing. We're using batteries that are available today. So we're not quoting future batteries. And we are assuming that there are reserves where if you needed to do, an alternate landing, if there was in the way when you were landing, that you could do that and fly to another site alternately. We also assume there will be some capacity fade that's considered in the batteries. So, if you have an iPhone today, it's different than, it won't work as well a year from now because the battery life will be a little bit worse. So we take all those things into consideration and we incorporate that into our range. And, we even put our range equation on our website. So you could even see kind of how that's calculated.
Oh, that's cool. And, there was a lot of earlier technical stuff in the day's presentations about some of the trade-offs of battery and energy density and range and whatnot. So 60 miles, can you give us in your mind where you see the important breakpoints of battery energy density, maybe in watt hours per kilogram, kind of what energy density is capable of the 60 mile that you're testing now? And then kind of, I don't know how that changes non-linearly if we got to some of these targets that Elon Musk has, let's say on 400, 500 watt hours, or if you really want to go further on the solid state of getting towards, 1,000 watt hours per kilogram, kind of how that expresses itself in your form factor.
Yeah, I think the important thing to think about is like sizing an aircraft for the right requirements and the right business case. For us, we were really excited about the urban air mobility missions of moving people kind of in and around cities. And that's generally looking at nominal missions between 20 and 40 miles. So taking folks from San Francisco to San Jose, Manhattan to JFK, like these different various routes that are just taking too long today on the ground just because of sheer congestion in cities. Batteries where they're at today is at a point where you can make kind of the range work for these missions today with batteries that exist.
So there's not a moonshot. There's not a moonshot required. You're not betting the company on some battery technology path that's outside of your control.
We are not here at Archer today. We are designing a vehicle using today's technologies that can get us 60 miles of range with existing batteries. Existing battery technology that we see come across our labs are kind of around specific energy density of 250 watt hours a kilogram. To the extent that you mentioned the specific energy increases throughout time, there are a few things we can do. One is we can go further in terms of distance. So instead of 60 miles in the most conservative case, we could go further. And that would be, from a physics perspective, a non-linear relationship to cruise, as you're using most of your energy today for reserves and takeoff and landing. So there'd be some of a non-linear relationship as batteries get better, that we would go much further than the advancements the batteries are making as a percent increase. And the second thing is we can also do the same exact missions for cheaper, given that the cycle life of the batteries will be higher, we'll use less energy per flight, we can make it more affordable for the users. And we could also theoretically redesign an aircraft for more payload as batteries become better. So you have a situation here as the technologies or underlying technologies improve, the product itself gets way better. It's cheaper, it goes further, it expands the possible routes. So it's a really interesting area today where we feel like the underlying technologies are good enough to make the whole service work really well. And as batteries improve, technology improve, the service will get cheaper and just overall better for the consumers.
Thanks, Brett. Just a couple more for me, and I'm going to pass to Christine. Total cost of ownership. How would either total cost of ownership or maintenance, basically costs of your aircraft compare to, let's say, comparable rotorcraft or fixed-wing aircraft solutions right now for the missions that you're targeting? Yeah,
it's a good question. So we think about the industry likely comes to be in the form of a network solution. And so We think that's important because safety targets are going to be really necessary to, make sure these vehicles can come to market with minimal, incidents. And so when we think about building these aircraft, we add up all the different costs. We look at everything from, the airframe, the batteries, the maintenance, all the way across. And it's actually, somewhat reasonable at even today's levels, low scale volume. It costs, we think, around $2 million to build these aircraft. Now that's at very low volumes, hundreds, of planes being built on an annual basis. Mm-hmm. So over time, the vehicles will go down in price. We think about, the avionics suite is very expensive today. If we are building thousands of planes, I think that will come down considerably. But I think the batteries are what really going to drive, the bulk of the cost here, and maintenance will also be the other big driver here. And so, batteries, as they get better and they last longer, will just be replaced less. It'll drive the cost down. And then maintenance, I think, is probably the biggest unknown to the whole industry. So how much maintenance will be required for these vehicles? Now, it makes sense to think that, okay, if we looked at like a Tesla is all electric, it has much less maintenance than a traditional ICE car. Something would be similar that you would see here. Now, an Archer vehicle, or pretty much any eVTOL vehicle that's all electric, has significantly less parts than a helicopter, right? You'll have likely significantly less maintenance than you would have. You also have zero critical parts, so zero single points of failure parts. So a helicopter might have 200 to 300 single points of failure. These vehicles will have zero single points of failure. So overall, I think the assumption is that your maintenance will be considerably lower. So your cost of owning and operating these vehicles on an annual basis, I think, should be considerably lower as well.
Great. We have almost 300 on the webcast, by the way. I'm kind of blown away. That's fantastic. Christine, I'm going to, and we have about 12 questions and rising. Now it looks like about 15. So I do want to try to get to as many of those as possible. Christine, I'm going to pass it to you to kind of explore some of the airspace and certification type of questions and anything on your mind. And then I'm going to open up the audience and see where we go. Christine.
Thanks, Adam. And maybe I could start, guys. Earlier, we've heard from some presenters, you're seeing different business models come about. You've got manufacturers, operators. We've heard from both. And I think you're our first speaker today where you're an operator and manufacturer. But at the same time, you have the order from United, which kind of mirrors more of the traditional manufacturing route where you've got, third-party customers. How do you guys think about your business model evolving over time? And what's your priority? Is your priority to be a vertically integrated manufacturer operator where Archer as the operator is the primary and then you're selling to others like United? Or is the route in the future to be more like that manufacturer selling to third parties? How do you see that market evolving and where do you think your value proposition is?
Yeah, it's a really good question. So core to what we're doing here is we think it's really important to operate the businesses across the network and have a party that really understands the safety considerations that go into there to make sure it's a really safe network. The last thing we want is any possible issues with folks like third parties or individual owners doing this and causing any disruptions from a safety perspective. Core to our belief here at Archer is that we want to design and manufacture and operate the aircrafts across our own network. And we announced earlier this year, we'd be launching into both Los Angeles and Miami in 2024, both huge markets with a lot of existing real estate and really big traffic problems we can really help solve throughout those two cities. We do intend to start operating the aircraft as soon as 2024 as we enter the market. Our deal with United is really special. I mean, United is not only a very large commercial agreement for us, but also a strategic investor in the business, helping us think about things like the go-to-market strategy across cities, pilot training, maintenance, and even some of the certification level requirements we need to get through. And it's very strategic to the business here. So we think it's a really important relationship. They strongly believe in electrification of transportation and aerial mobility, and we really want to help work with them on making sure they're successful in taking these aircrafts and operating them into the airspace. So we think the United relationship for us really adds a really predictable revenue channel for us, helps spin up manufacturing faster and get down the experience curve of the cost curve quicker, which is also really important, help fund a lot of that CapEx. But at the same time, think about running our own operations and scaling that over time, which we feel is a very profitable standalone business over the life of the aircraft that, ultimately at some point is going to be really important for the consumer experience to have a, just a really great experience on this, make it affordable for the users, make sure they save time, make sure they want to use it again as a, something they use every single week and every single month in their life.
No, that's really helpful. So when you think about initial operations, and let's say you have your aircraft certified, so flying in existing heliports and airports seem to be the logical next step, but to be able to transition from the existing routes that certified aircraft can fly today towards what you described, which is more in this operations in urban areas, what kind of airspace regulation changes do you anticipate that you will need in order to be able to operate in dense urban areas like New York or San Francisco, where you have more restrictions in use of the area and also limited helipads or airports that are closer to the center of the city?
Yeah, so I think infrastructure to start is a good question and one to start thinking about. So I think you're right when you pointed out existing infrastructure solutions like underutilized airports, highly utilized airports, helipads are good starting points. But I think also you can look at parking structures that could be retrofitted, lightly retrofitted, to become vertiports or takeoff and landing spots for this industry. So it doesn't take a lot to convert the top level of a parking structure, which generally is the most least utilized part of a parking structure, to become a vertiport. You need charging infrastructure. These are lightweight vehicles. The vehicle will weigh around 6,000 pounds. To put that in comparison, a Tesla Model X might weigh 5,500 pounds. So they're lightweight vehicles that can be supported by existing infrastructure. I think the other thing that's important is that helicopters exist today and urban air mobility exists today. It's not really accessible to the masses. It's very expensive. They're also very loud, so they don't scale. So you couldn't have, 10 helicopters at a time flying over New York City, but you certainly have a few. And I think, for the folks that have lived in New York City, you've experienced that while just laying out in the park. And so there is existing infrastructure. There are existing routes. If you take a step back and you just look globally, there's something like 50,000 helicopters that exist globally, right? And so these are, I think, far superior vehicles than helicopters as they're highly redundant and safer, they're lower cost, and they're lower noise. And so just going through the replacement cycle of that, you have a pretty significant business that will start to take place. And then the TAM expansion story really starts as the business becomes more affordable and accessible to the masses. So I think you have time to help that regulatory environment, grow, where there is more airspace that gets opened up, and there is more understanding of how to do that. We see all the time the FAA and NASA are working on expanding these routes. They're working on even additional solutions like autonomy. How will that be rolled out one day? And so I think we have time to get to that. But the good news is there is existing infrastructure. There are existing routes that people fly today. And just this early stage into the market where we start to replace helicopters, I think is a massive business. I think the biggest gap that needs to happen here in general for the industry is there needs to be this closing of information where the mass understands that this technology exists today, that you can see these vehicles, they can fly around today based on today's technology. We're not waiting for any breakthroughs. The infrastructure exists, the regulatory framework exists, the technology exists, and simply we're all going through the certification process. And in 3 short years, you will see these vehicles out there flying, taking passengers.
That's really helpful. So with that in mind, what are the key challenges that you see in aircraft certification? Are there pieces of technical requirements that are more difficult than others that you're focusing on?
Yeah, I mean, it's a really good question. And I'll speak for Archer here, not on behalf of other groups, but we, we're going through a process now with the FAA on certifying our piloted plus 4-passenger aircraft. And we have a lot of folks at the FAA working on our project. We're certifying the aircraft under Part 23 standards, which is how the FAA would certify basically a general aviation airplane today. And there is no meaningful gap here from now until that period of getting a type certified aircraft in the coming years that we need to kind of, solve with FAA. We're largely on an execution path to show compliance against the rules we've set up. And we think it's more of a matter of time now going through the process to exhibit that safety bar that the FAA is so interested in, and making sure we deliver a very safe transportation solution to the U.S. In 2024. So for us right now, we're largely in a more like an execution phase with FAA as we're working down the right steps here to bring a very safe product to market. So we feel very great about the process we're making. We talk to the FAA every single week. We have a whole team dedicated to it internally. And it's only a matter of time now as we get to market and have it certified products that consumers can use.
And what key milestones should we watch to follow your certification progress?
Yeah. So I think what you'll see from us and from other kind of players in the industry is there are certain milestones that, we'll all kind of go through, whether it's the G1 or G2. So you have your certification basis and your means of compliance that need to get, you need to go through. I think the other thing that you'll need to go through, just in general, you will see a lot more public demonstrations. And so it's not necessarily a certification comment, but I think it's more of a consumer acceptance comment where you'll start to see the vehicles being flown around more. So you'll have some of these, hurdles through the FAA, which we will go through, and then ultimately leading up to your type certificate. But then I also think you will start to see a lot more visibility of these aircraft out there. And right now, you don't really see that. So something we've talked a lot about internally is, live streaming our flight tests. We think that's a really interesting concept that is not really done in the industry. SpaceX does it. And so there's interesting things there. So that's a concept that we're considering as a way to try to help, bring the consumers closer to seeing these vehicles come into the public and start to understand that the technology exists and understand that, the industry is actually pretty close and not that far away.
Thanks. Adam, I'll pass it back to you for any questions. And I know you have questions on the web as well.
Yeah, I mean, I'm deleting a lot and consolidating. There's 30. I don't know. Something went viral here. So I hope our servers didn't break down if I'm twitching. Look, about half the questions do mention directly or indirectly the WISC litigation. So I'd be remiss, and there's some major Morgan Stanley clients that are also asking this. So I'm just going to consolidate it into one broad question. What would you like to say today to address anything related to, or what can you say to address anything related to the WISC lawsuit?
Yeah. So I think a few things here. One is only so much we can say, obviously, as we're going through ongoing lawsuit. We can say publicly. What we will say here is that we were working on filing a response to the claims that they made that will be made public. And we feel very strongly once we respond publicly and once the folks have time to go through it, that the world will see that the claims they're making are completely baseless. Archer's been in an incredible period of time here, last like 3 or 4 years, as we built a great team, produced some great technologies, and we've had, some great partners we've brought on, and obviously coming off a big funding raise. Shortly thereafter, we had a group, make an attack on us. I think this happens that, there's a lot of precedent for folks, maybe going through ups and downs of different companies, attacking different groups at different periods of time. But, we feel very strongly here that we've done nothing wrong internally, and the claims we're making are baseless. And with time here, we will show the world here more information as it relates to that.
Great, I appreciate that, Brett. So I think you did a really good job explaining, and one of the themes from this conference so far is that path to replacing helicopters can happen pretty quickly. Like if the bar of safety and cost and efficiency is a gasoline or whatever powered or petrochemical powered rotor aircraft, then wow, that portion of it can move rather quickly. Again, going back to maybe a point Christine made, just to go a little further, I'm left with the impression that you might very quickly, in terms of type certification, say, look, we've got something that works and it's way, way better than helicopters. And so you have this, 30 or 50,000 unit kind of installed base global market you can kind of tap into. And that's something that can really that can light enough of a wick, right, to then open up other opportunities down the road. I'm just wondering I'm left thinking in that gating bottleneck, though, of even if it's quieter, even if it's safer, just having the numbers of vehicles from again, airspace and flight operations for VFR and IFR, kind of, how does that get pushed? We're left with the impression from some earlier speakers that you just might have to push them first and kick the bear, if you will, and then see what happens. Is that the way it works, or or is it really can happen over a gradual enough time that the two can iterate together and you don't have this stall speed point where you're left with these great aircraft, but then the market just is too small or just it underwhelms? That makes sense?
Yeah, I think one of the things that Archer spent a lot of time doing was really trying to understand the market that we were going after and designing a vehicle that was specific for that market. So, I think right now there's a couple of different solutions out there. Some vehicles that are designed to go, do regional flights. Some vehicles like Archers that are designed more for urban air mobility missions. And so I think that's where we looked at, this industry and said, we think there is a huge demand for it. We think there's existing infrastructure. We think there's existing airspace that we can kind of go into right away. And so when you look at it, to us, it really kind of doesn't really come down to a demand issue, but I think it's really more of a supply issue, meaning like, how much production can we get out? And then also, like Brett mentioned too, making sure our vehicles have impeccable safety records. And that's another big part of why we partner with United. And so if you think about the different things that can kind of slow you down, I think safety is a really big one there, and making sure you do a really good job from a safety perspective. But if you assume all that stuff is true, and then it gets down to production. And so can you make 10,000, 20,000, 50,000 vehicles? How long will that take? So today, if you look at the small aircraft manufacturers, they're making hundreds of vehicles. I think it's pretty well understood how to make 200 or even 400 or even 500 vehicles on an annual basis. And let's say you needed to make 1,000 vehicles. Okay, you could put a couple factories next to each other and make 1,000. But what's not well understood is how to make 5,000, 10,000 vehicles per year. That just simply hasn't happened since World War II. Now, the good news is the autos have figured out how to scale production, and they've already worked on things like robotic automation. Now, it hasn't been transferred over yet to aerospace, but I don't think that it's not possible. I just think that there hasn't been demand for it yet. And so that's what the partnership with Stellantis is all about. How do we work on, solutions that can enable high-scale composite manufacturing, that can enable, a much larger scale manufacturing solution to get to that point where we can challenge and see how deep that demand base really is. And that's what we're really working towards. But I think everything will come down to safety. Safety is the key to making sure you can expand. And I think beyond that, the product will really speak for itself. It's lower cost, it's lower noise, and it's safe.
Brett and Adam, got a question about the global TAM. Do you see that over time, urban air mobility will resemble, let's say, airlines in foreign markets where, let's say in India, the regional or Indian airline market is just not, it's dominated by local, say, state players, and the same for China. I mean, there may be some exceptions with like hop routes or whatever, but due to national security concerns or nations that want to control their own destiny, and there may be, depending on the size of the nation, right? But the larger economies or the larger, literally geographic spaces of the economies where it matters, where you really don't, where a U.S. player doesn't have access to the full global market, are you dealing with a subset? And the same for foreign players that might want to get into various U.S. regions.
I think it's a good question. And it's interesting. Every time we talk to somebody, they always tell us, oh my God, in my hometown, that would just be so great. It would be so beneficial. Pretty much every industry we talk to, people say, oh my gosh, well, if we could just have that within our industry. I think the use case for this product is just so big and so much different than airlines. What's exciting about the product is it requires minimal infrastructure. So yes, I understand airlines might be limited in foreign countries, but they also require massive amounts of infrastructure and massive amounts of coordination. These vehicles, though, won't necessarily need the same type of infrastructure, right? So if you were talking about rural areas, I know we've talked a lot about urban areas, but even if you were talking about rural areas, Brett and I talk about it all the time. Brett grew up in a much smaller town, and it took a long time to get into town. And if you could fly that type of route, man, wouldn't that be interesting? That's not the typical type of use case we talk about today. We are doing a lot of work, though, internally to model that out, to try to understand that. So you have to think about things like deadhead flights and how can you make the economics work there. But I think the demand is just so large, and there's just so many use cases. I think even if you looked at like DoD use cases, right? Disaster relief, rescue vehicles. I mean, there's just so deep the amount of use cases that we can go here that I don't think that this is just going to be concentrated. I think that this has global implications, and I think it goes beyond, just the kind of large city type environments.
So our next presentation after this is with Blade. Curious your views of infrastructure operation and infrastructure, real estate, and the kind of more agnostic but necessary parts of this ecosystem. Is that something that you would seek to do through partnerships, or Could Blade, for example, or someone like Blade, be a partner with you as you kind of supplant existing helicopter routes and operations, or is that part of your model within your vertical integration?
Yeah, I mean, it's a really good question. I think it's going to be a mix across the board. I think in some areas, real estate would be very scarce. It'd be really important to control some of that. And other areas might be less likely or less interesting to do that. And I think it's a balance we're weighing internally and trying to simulate different networks across these cities, the type of real estate we need at certain places in the cities, type of charging we need, type of maintenance facilities and those things. But I would say it's largely going to be a mix. There's like 3 phases of real estate that we're looking at. There's a phase 1 of just like a lot of existing real estate. There's a lot of underutilized airports and helipads inside of cities. Phase 2 is thinking about just doing retrofits of land parcels, parking garages, rooftops, and things that have just land. And at the end of the day, we're landed on a 50-foot diameter, and we need that permitted and authorized for use. And then third is there's been a lot of push from big real estate developers to build large-scale takeoff and landing facilities that can accomplish hundreds of takeoffs and landings per FATO per hour. So there's really interesting different dynamics of real estate that can fit in a city. It will affect the network significantly. It's an area that we've spun up a team here to focus on, as well as a simulation team to help simulate what that might look like inside of cities. But I would say overall, it's going to be a mix. And I would have to assume there'll be some really important partners in our future helping us along through that journey.
Christine, I wanted to give you one more shot from your lens to ask the Archer team.
Sure. So, Brett, Adam, when I think about the tens of thousands of aircraft that you're looking out in the future in this potential market, how do you think about your supply chain, right? Because that is an unprecedented rate in aerospace. And unlike autos, you do have to have your aerospace manufacturing line also certified by the FAA. So when you bring that out and ramp up, how does that supply chain look like? Do you anticipate to be a vertically integrated manufacturer? We're also doing your propulsion, or do you expect to seek third-party partnerships for things like propulsion, avionics? And then also, how much is it going to cost to ramp up a production line of tens of thousands of aircraft?
Yeah, I think it's definitely a good question and something we're thinking about. And it's a question that we've seen kind of across the industry. And there's been a lot of forums to talk about this. I know the DoD has had lots of conversations about this, to think about the supply chain here too. And so I think the way that we've thought about it today is that there are key enabling technologies that we want to make sure that we can control our destiny on. So things like batteries and things like electric motors. And so right now, there's not a great solution to go buy an electric motor off the shelf today. And so that puts us in a position to go out and start working on developing them. And so there are groups out there that are spending time and working on them themselves. And there might be some solutions that do pop up along the way where there's great opportunities to look at that. But right now, because there aren't very many solutions, it's stuff that we are building a lot in-house. Now, we have to balance that against biting off too much. And so when we think about things like a flight computer, there are flight computers we could use today that are certifiable that we wouldn't have to go reinvent. So we don't want to necessarily reinvent everything, but we also don't want to necessarily just supply all on third-party supply chain. So I think it really is a balance that we're striking, and we are watching as the supply chain does develop. We will help enable that supply chain. But I do think that is an important question and something that, that we haven't been focusing on. As far as like ramping up large-scale facilities, I think, if you look at some of our production numbers that we've put out there, through the end of the decade, we estimate that we'll produce, 5,000 aircraft. And so, you could say only 5,000 aircraft, or you might say that's a lot of 5,000 aircraft. But I think that's a number that is like something that's doable, with today's aerospace, kind of volumes, meaning like we can produce hundreds of planes using kind of traditional aerospace volume production. And over time, we can start to think about the high scale, production facilities. So we're not building the high scale production facility today. We are doing a lot of work on figuring out the best way to set that up. And so I think that comes in stages. And stage 1 right now is building the first level of these facilities, which will enable us to produce this, first amount of volume that we've talked about. At the same time, conducting that research to try to understand, with some of our partners, how to build, the high scale volume facilities.
And what about the service network to support flight? I mean, once you've got thousands of volumes out there and they're going everywhere, how much is it? How are you approaching the service network? Do you plan to build that in-house as well, or work with third-party companies? And then, what's kind of your reliability threshold to be able to fly these aircraft at high utilization?
Yeah, I mean, it's a really good question. I think it comes back from a safety question too, from the maintenance or the MRO type scenario you're saying here, which we think is really important to have a group really dedicated to operating the aircraft and not have this be used for, say, private use and other different parties flying these around wherever they want. And so I think it's going to be really important here for that. And from a utilization perspective, we are designing the vehicles and from scratch to get high utilization across the network. I mean, I think it's really important for us to build a really profitable business is to have the aircrafts in operation as much as possible. And so we are trying to design a network and load factor and even aircraft to hit on those requirements and generate a really profitable business, which in a lot of these cities, there are millions of people traveling every single day for hours, like a long time. So moving those folks into the air and hopefully large quantities is a goal for us, and building a high utilization, high load factor network is imperative to lower costs and make this affordable to everybody.
Thanks. And earlier with my vertically integration question and the business model, we have a question from the web that kind of looks at the Airmail Act of 1934, when kind of broke up Boeing and United and the United Aircraft Transport Company. What are the implications of that for having an OEM and airline together? Is that something that's been addressed by regulation so far?
Yeah, I don't have a great answer to that question, so I can't necessarily answer it directly. I think the industry is early in terms of developing that, and those are the types of questions that we will certainly work on here and study. I think the reality is, we're at a point in time where we need sustainable forms of transportation, right? I mean, the Earth needs this, and I think electric cars on the ground are a great solution, but it also doesn't solve traffic issues. And so we're at this point of time where we do need to move to the air. And so the air is a way where you can kind of keep vertically compiling your code and expanding. You can't really do that on the ground, right? Your cities are we live in these 3D cities, yet the transportation grid is still stuck in 2D. And so I think we will certainly work open-minded with open arms with the regulators to try to accomplish these goals, because I think it is a necessary thing. We're at a point in time where this is necessary, but I think it's something we'd work openly with the regulators on.
Okay, Brett and Adam, there's so many more questions. I guess just one only. I didn't want to ask this because I thought we could follow up, but since I've been getting it in such high frequency, people were asking about when the merger date is, and I didn't know if there was anything you could comment on right now, or anything specifically or directionally.
Yeah, I mean, we're still on track. Everything's been going extremely well, and we do expect to close in the near term. And we're going through the processes now of working with SEC on get our revisions in and making sure that S4 is in place and to go through closing. So I think so far so good. There's been a little bit of a last few weeks. There's been a whole warrant treatment issue that everybody's been trying to work through. That's largely now solved, and everybody's kind of back, or at least we're back, and moving that forward here. And we expect to be in the near term here to be going through closing and getting this fully complete.
Well, great. I mean, I do appreciate you enlightening us on this really exciting topic and your role in it. Can't wait to see the aircraft in action, and looking forward to the event. I believe in the LA area, so that sounds like a real must see. And so thanks again for joining us and for being a part of the UAM Summit with Morgan Stanley. And this ends the presentation.